Electrostatics. Question number 1. Calculate the flux when charge Q is placed at A, one corner, B, midpoint of one side, C, at point C as shown. So three cases we have to discuss. Case A, when charge is here. Case B, when charge is here. Case C, when charge is here. Now, when charge is at one corner, then Q by 8 charge will be included in 1Q. So flux will be 1 by 8 Q upon epsilon naught. Second case, when charge is placed at B, then 4 such cubes will share this charge. So 1 cube will have only Q by 4 charge. So for this, I will be 1 by 4 of Q upon epsilon naught. When charge is at C, then this charge will be shared by 2 cubes. Hence, for 1 cube, contribution of charge will be Q by 2, and so the phi will be equal to 1 by 2 Q upon epsilon naught. These questions are important for the competitions. Now, let's see next question. Two parallel infinite line charge densities lambda coulomb per meter and minus lambda coulomb per meter are placed at distance 2r in free space. What is electric field midway between two charges? So electric field midway between two charges to be found. Suppose this is the point where we have to find out electric field. So electric field due to infinite charged wire is given by E equal to lambda upon 2 pi epsilon naught r. R is the distance from the wire. So here we know that in the right of the wire, the sign of lambda remains same, but in the left, it becomes negative. So for this charge density lambda at the point P, electric field will be lambda divided by 2 pi epsilon naught r. And for this charge density minus lambda in the left side, we have to change its sign. So it will become plus lambda divided by 2 pi epsilon naught r, and that will become lambda upon pi epsilon naught r, small r, coulomb. But this is midway, so it is capital R, small r equal to capital R. So this is capital R. Now, as I told you that this charge will change its sign, we can understand it by the direction of electric field. This is positively charged wire, so its direction will be towards right. This is negatively charged wire, so its direction will also be towards right. That is why total electric field will be lambda upon 2 pi epsilon naught r plus lambda upon 2 pi epsilon naught r. That gives lambda upon pi epsilon naught r. Now let's see next question. Next question says, a hollow cylinder has a charge q coulomb within it. If phi is the electric flux in the units of voltmeter, volt dash meter, associated with the curved surface B, the flux linked with plane surface A in units of voltmeter will be. So here, flux through this surface is suppose phi A, and flux through this surface will be phi C, but phi A equal to phi C. So I'm writing it as first phi C, then I will change it as per our need, and plus phi B must be equal to Q upon epsilon naught. But we are given phi is the flux in the units of voltmeter, so it is curved surface. So phi B is phi, and phi A and phi C are equal. So 2 phi a plus phi equal to q upon epsilon naught, or 2 phi a equal to q upon epsilon naught minus phi, which further implies phi a equal to 1 by 2 q upon epsilon naught minus phi, which is our answer. Now let's consider next case. So question is, the electric field components in the given figure are Ex equal to alpha x power half, Ey and Ez are 0, where alpha equal to 800 Newton per coulomb meter square. Calculate the flux and charge within the cube. So here we have to calculate the electric field at left face first. So electric field at left face, suppose we give the name it as EL. So it will be equal to, it depends on its alpha times its distance from origin is A. So in place of x, we will write A power half, where alpha is 800. So we can write it 800, and A is also given as 0.1 power half, and the area of this face is, say, A, which is equal to A square, that is 0.1 square. Now direction of electric field and normal drawn on this face are opposite, so theta will be 180 degree. Now if we evaluate flux, we denote it phi L, so it will be EL A cos 180 degree, and cos 180 degree is minus 1, so it will become 800 0.1 power 5 by 2 with negative sign. Similarly, we calculate electric field on the right face alpha, and the distance up to here, distance of the right face is 2a, so we write here 2a power half, and the area of the face is a square, so a square times theta n cap, and electric field both are directed in the same direction, so cos 0 degree, that will give 1. So we write it 800 times root 2 times a power 5 by 2, and a is 0.1, so 800 root 2 times 0.1 power 5 by 2. So total, so this was not electric field, but electric field, this is total flux phi r, because electric field will be just this one, alpha times 2a power half, and this is area E A ds cos theta. So here EDS cos theta will be this much. Now we have got flux through right face and flux through left face. To total flux, phi total will be difference of the two, phi right minus phi left. That will be equal to 800 times 0.1 power 5 by 2 root 2 minus 1. So if we put the values, then we will get 1.05 Newton meter square per coulomb, which is our answer. Now, in order to get charge, Q equal to phi E. So phi we have got 1.05, sorry, phi epsilon naught. So 1.05 into value of epsilon naught, that is 8.85 into 10 to the power minus 12, and epsilon naught. So this will become 9.27 into 10 to the power minus 12. So this is our answer. Now let's see next question. A charge q is placed at the center of an imaginary hemispherical surface. Using symmetry arguments and Gauss's law, find the flux of the electric field due to this charge through the surface of the hemisphere. So if we imagine complete sphere and charge is enclosed in between, then total flux phi e would be q upon epsilon naught. Here it is hemisphere, so flux through hemisphere will be just half 1 by 2 q upon epsilon naught. Now let's see next question. An infinitely long positively charged wire has linear charge density lambda coulomb per meter. An electron is revolving around the wire as its center with a constant velocity in circular plane perpendicular to the wire. Deduce the expression for its kinetic energy. Plot a graph for kinetic energy as a function of charge density. So suppose this is positively charged wire and electron moves in circular path of radius, suppose small r as electron. Now, so we know that electric field due to infinitely long charged wire E is given by lambda upon 2 pi epsilon naught r. Now, force on electron F will be QE. So, F equal to Q times lambda divided by 2 pi epsilon naught r. Now, this force will provide centripetal force. So, we can say that mv square upon r equal to q lambda divided by 2 pi epsilon naught r, from where r will cancel out, and if we make it as kinetic energy, that is 1 by 2, we can multiply by 1 by 2, so 1 by 2 here also. So ke will be equal to q lambda divided by 4 pi epsilon naught. Now clearly, Ke and lambda, here we have to plot the graph between kinetic energy as a function of charge density. So Ke is directly proportional to lambda. So graph will be straight line like this. If this is lambda, this is Ke. Now let's consider next thing. Positive charge near an uncharged conducting plate. Suppose this is uncharged conducting plate and there is positive charge here. So this positive charge will induce negative charge on this conducting plate, and field lines will be like this. Now, suppose we consider another case, two metal plates held tightly placed between two opposite charges. Now, suppose this is one plate and there is another plate. So this is first plate and there is another plate placed in its vicinity, and this is suppose P1, this is P2. And now here there is positive charge and here there is negative charge. So what will happen? Here field lines will come like this. And from here they will go like this. I think you must have understood. Thank you for watching.